very easily.
Exactly.
But now I cannot present it because I don't have the example. I don't understand the.
So.
If you go down, it's just the definition. You can go to the next chapter. This is also, I added your abstract, Dr. Lu. So, okay, maybe with this example we can go, yeah?
Yeah. Step 4, what is step 3?
Let me just become sure it's recording. Yes, okay.
Yes, I think I can understand step 2. Step 2 is talking about the.
So if I give you like the big picture, the overview of
I already know the big picture. I want to know the details.
Yeah, but we can, like, for example, maybe.
The big picture is very easy to understand because in the beginning you have 6 methods. And all those methods they call each other.
Influence, update.
Yeah, but like in terms of, for example, how the new generation is, like, for example, generated, and what happens, for example. Yeah, what we do is that first of all, like at the in the beginning, in the initialization stage, what we do is that we produce uniformly, randomly some solutions in the space.
Right.
So yeah, we make sure that we have some data points everywhere in the space.
Mm-hmm.
And then these are the trial solutions, right? Mm-hmm. The trial solutions, so we have the make span and the cost, like for example, to calculate. So the fitness function is calculated for each of these trial solutions. Yes. So it's attached to them, is a part of their data structure.
Mm-hmm.
So what we do is that we're gonna rank these trial solutions in the first step. So based on their fitness score.
Mm-hmm.
Okay. So right now, because we are using your fitness score formula.
Yes.
The one that has higher value is the better one.
Yes.
So we need to maximize that. In this case, so they are sorted based on the fitness score. So what we do is that we have another factor or another to choose the number of the elites or the best solutions out of the whole trial solution, the population that we have. For example, we need 20% of these.
Mm-hmm.
So we consider 20% to affect the belief space.
Mm-hmm.
In the reality is that if we have a culture that we have people, out of these people, only few of them they become elites, and the other people they're gonna follow them because they have good performance in the society. So we choose this 20%, and we try to, out of this 20%, the best one is going to become the situational.
Yes.
Is the leader, is the supreme leader.
Right.
So it's going to be the situational. The rest, we're going to use them to define the ranges between, for example, for each task, let's say I have, for this example, we have 7 tasks and 5 machines, right? So the vector for each solution is made of 7 cells.
Mm-hmm.
In each cell, we should put the number from 1 to 5, which is assigning or mapping each task to a machine. So let's say out of this 20% that they did good job, we want to see what are the ranges of machines used or assigned for each of tasks.
Mm-hmm.
So among these 20, I see for task 1 they only used between 2 and 3 only.
Mm-hmm.
They just discarded the other, ignored the other.
Yes.
So it gives me some information.
So suppose you have the situational knowledge. You also have the, what do you call, the normative knowledge?
Yeah, this is the normative.
Yeah.
Now.
So suppose you have both.
Yeah,
of
the
them.
situational is the best. Is the best guy who did the best performance.
Yes.
We need to, in the next generation.
I think I reached the point that already.
Yeah, exactly.
I know how you calculate the situational. I know how you calculate normative.
Yeah.
And I also know how you use the situational to influence the new solution.
Yeah.
But I don't know how the normative is used.
Yeah. I will talk about the normative. So you know about the situational because in the next generation we try to make every solution closer to the leader, so resemble the leader, the
Right.
supreme leader or the elite, the best elite situational.
Mhm.
So they're gonna take a step by step to get closer to that guy, to resemble the elite. So maybe in that path they also will become themselves an elite by themselves, the best.
Yes,
Yeah,
yes.
in that because we are like a kind of exploring the situation. We have exploration in the
Right.
population. So that's one part. The other part is that okay, so we want to take a step. This step should be small, should be big. So that's why we have something because it's a part of the influence. So from the like we want to use the information from the belief space to influence the population for the next generation inside the population space. In this case, okay, I want to define the step that I want to take. Should I take only one step, like step by step? So let's say machines are kind of they are have a they are sorted in a meaningful way. For example, from the most expensive to the less expensive, or the best in performance to the less for example, performance, and so on. So we have some sort of order in this case from 1 to 5. And we want to like go from, let's say, 1 to 2 to 3 to 4. So it means that I want to change one of these tasks and map it to the next machine. So this next machine should be the next in terms of 1, 2, 3, 4, or I should jump. I have to take a bigger step. Like before, for example, let's say in the more complicated situations with a more complex workflow, we have thousands of tasks and hundreds of machines, or at least hundreds of machines. So if I am too far from the leader, or the like, let's say the average of the average machine number of the whole elites, the 20%. So if they are using something around 85, number 85, 86, something like that, I'm 1. Should I just start from 1, I go to 2, to go to 3, to 4, and take small steps? Or sometimes I should jump, like go by 3, like a kind of, I took 3 bigger steps, or maybe I took the whole thing, I divided the distance between me and the average or the leader, and just chop it in half and take that much step, for example. Okay, so that's one way, because sometimes we need to go faster. So in this case, what we do is that sometimes we need also to generate randomly this like a step. So it's not always to go directly this way. Sometimes you need to go to the other directions, which is like we have 8 directions in this case. So what we are doing, we have, I just defined 4 different influence functions, not just one. One of them is just taking one step based on, for example, you are ahead, for example, in terms of the machine number. You are ahead of the leader situational, or you are behind. For example, you are number 4, the situational is number 5.
So are you still talking about situational, or are you talking about normatives? No.
I will go there because this is a need, like a kind of you need to know, like for example, this is one way. I'm talking about the influence functions. One of the influence functions ignores the normative. Okay, it just takes one step. For example, if I am, let's say, behind the leader, I will take one step forward. If I am ahead of the leader, I will take one step backward, so to get closer. So this is just one step. I'm using only the situational. The other one is that, okay, I will define, for example, I will have a formula to take a step. It's called delta x. This delta x is actually how we calculate that. We will have like a, for example, a factor called alpha. Okay, it's a scaling factor that is defined by the user for example, how much we should like go. For example, what the fraction of like the step that we should go forward or backward. And also we have the normative here, which is from the normative we have the max number of the machine assigned to the task and the mean number. So we are having a range, right? The mean number was number 2, the max number was number 4 for the task 1. So task 1, these elites they used machines between number 1 and number 4.
Mm-hmm.
4 minus 1 is a 3. So you have, like, for example, you have a 3 steps to get there, right? So for the range is for example, between number 1 and number 4. So we use this size, okay?
But the optimal one might not be. Is it possible the optimal one might not be on one end of the machine?
Yeah, for sure.
In other words, giving the range, for example,
Exactly.
from 2 to 5, maybe the optimal one is 4.
Number 3, exactly.
Maybe
So
in the
that's
middle.
why we are using it. Yeah, exactly. So we want to see the ranges that are used because these are for different tasks. So different tasks, they have different ranges. So maybe in next generation we can have a number in between, and then that, like, a solution will pop up as a, for example, elite or super elite that's gonna serve as a, like, leader or the situational. Okay, so it's actually the path that we are just taking to explore. So in this case, we have a range. We know that this is the size, which is called the size in our, like, algorithm, the max minus min. So as I mentioned, we want to define the step based on this. Okay, I have a big range or I have a small range.
Mm-hmm.
So we need to multiply that alpha by this range or the size.
Mm-hmm.
Okay, so we say, okay, we need a fraction of this.
I see. So if the range is bigger, you jump faster.
Exactly,
If the range is small,
exactly.
it jumps
Yeah,
more
exactly. So we get that. However, we will multiply it by a number which is normally distributed. Okay, is a random number.
Mhm.
That it gives us, like, kind of like based on that normal distribution. So we know that the number is kind of more natural.
Mhm.
Okay, does it make sense? It's like, for example, we will generate a number that not always exactly cuts everything in half and then takes this portion. No, sometimes even goes backward.
Mm-hmm.
Because it's just by chance. Because we try to have diversity, we try to have randomness, because we believe that sometimes, especially in the nature, what happens is that they're gonna, like, make a better solution. So we give this chance also.
Mm-hmm.
Okay, so we will multiply this. So we will have, actually, because our numbers are discrete, are not like a real value.
Right.
I will take the round, like I will round them.
Round up or round down.
Yeah,
Okay.
so I will round them. For example, if I get 4.5, I will make it 5.
Okay.
Or let's say 4.3, I will make it like a 4.
Mm-hmm.
So because we are dealing with machine numbers that are just 1, 2, 3, 4, and they are. So this gives us the delta x.
Mm-hmm.
So I will, like, take that delta x and add it to the, for example, instead of that just one step forward, one step backward, I will give this delta x this time. So
Mm-hmm.
I'm using the normative information.
Mm-hmm.
Okay.
Okay.
Yeah. For the, like, the fitness score that belongs to each of those min and max, we had an idea actually to use it, like, to use a gradient.
Mm-hmm.
So, but the problem is that it doesn't make sense for these numbers, especially. Like, sometimes I came up with a lot of ideas, like, for example, to tune the algorithm to get better things. For example, to use maybe neural networks, to use, like, EM, the expectation maximization algorithm.
Mm-hmm.
So I tried to think about these things also, but the problem is that we are restricted with, like, numbers of machines and tasks that is not, like, kind of, for example, some values we want to just estimate, or something that is out of this bound, or this, like, thing that we have. So right now, as I mentioned, for example, we have 4 influence functions. One is just randomly, I don't remember, it was, if I can show you on the algorithm. We just mentioned one of them here. The first one, which is takes only one step, not normative. Okay? But we have 4.
Can answer me.
Hello? Hello? Yeah. usually all the phone call me is something like this. I don't know why.
Oh.
It's like maybe
Recent-
alarm for reminding
Recently you got it?
Huh?
Like, recently or no?
No,
Recently?
it's always like this.
Oh.
Is it
Either
reminder?
advertisement or just from the machine. Because people, they need to contact me. Usually they contact by email first.
I see. Yeah.
So it's strange if they just call me. But sometimes students call, but it's very rare.
I have the number. Yeah. So I have the main algorithm here. So if I go over the
So do you think you can change the pseudocode and the example so that we can
So
see
the problem
everything?
with this example right now that we have is very small. So it doesn't make sense to randomly generate something as a step. So we have a small step, like a step size. For example, we need
So
a more
complicated
so how about
example.
try this example?
This is
Okay.
maybe good, but even I think we need to go over a example which is more complicated than this, maybe 3 times, 4 times more complicated than this.
to show the merit.
Yeah, because what the good thing about the cultural algorithm is to, for example,
Searching a bigger space.
yes, guarantees that, for example, we're gonna get a better and better
So
answer.
so in other words,
It's not just randomly
it's,
generic algorithm.
It's good for better to large scale workflow.
Yes.
That's
Yes.
the advantage.
Yes.
Yeah.
The
When
search
the workflow is
space.
bigger, the EA will be
For sure.
More
Even for
advantages.
this is working. I'm not saying it's not working, but I mean, because I want to tune it right now. Let's say even maybe I will change the way that I'm gonna calculate the delta x, the step size. So
Okay.
sometimes maybe I can introduce some other parameters in
I
it.
see.
But right now I cannot do anything because it doesn't show any difference.
Because the workflow is too small.
Yeah.
So Marty, can you the chicken egg problem? Could you create a chicken?
Yes.
Meaning that create a bigger workflow
A big workflow.
for
Yes.
Saeed.
Mhm.
Then he can do more.
No, for sure. With this idea was to make it and go for the bigger and more complex.
For example, the workflow that Android worked, that workflow is much
Montage.
bigger. The montage workflow is much
yeah.
bigger.
Yeah. At least for our testing, the coding, you can
Yes,
see the
the
result.
example should show your advantage. So, for example, this paper, why I like it, because I try to beat this paper, I cannot.
I see.
I come up with a different algorithm using this
So
example.
we can do this
So-
also,
so-
but I mean yeah, for tuning the algorithm or for
To beat.
enhancing it or improving the algorithm, we need something more complicated that it
Exactly.
shows the weaknesses and the strengths of the
It's
algorithm.
like-
Otherwise,
like,
if I don't have
It's like play chess. In China, we have a book in which they have different layout,
yeah
and if you win those layout, you are a good champion.
yeah
So basically, well, I don't think his algorithm is going to work for everything, but at least for this
I
for
see.
this particular example,
It was
I cannot win it. I try to think very hard.
So you can win it. We are.
I just cannot win it. I think he's already got optimal at least.
I see. So we can do this and also the one that yeah
Montage workflow.
Right.
But
Same
to
for
show-
us. We cannot. Maybe if our algorithm can beat everyone in every case, great, right? But if not, at least
at
we
least it should beat some of these.
yeah, at least you have to beat on
I see.
some
Some-
cases.
So this is, for example, here. Sorry. So here, for example, I have the method 1, influence
Okay.
method 1.
Okay.
So you define this at the beginning in the the inputs of the the parameters to the culture algorithm.
Okay.
So it's defined by the user which one he want to use. So if you use 1, I'm going to use the normative size
Mm-hmm.
times the alpha. It will be my sigma. My sigma times the R norm, which is a number randomly generated and distributed normally.
Mm-hmm.
So I will round it and I will define it as my dx.
Okay.
So in this case, again, I will check if I am ahead or I am behind. So I will take that dx and add it to the, for example, as a step size to the number of current and number of machine of that task. So, and also I will define it as, for example, if it is less than the situational I will take the absolute of dx, whatever is generated. Sometimes it's generated as a negative number, right? Because it's a random number. So I would take the absolute, I would take the minus absolute, or I would take the dx if it is 0.
Yes.
So that's one way. The other way, method 2, which is currently is used, it's just I use 1. It's a step size, either 1 or minus 1. I go backward or forward.
Like the one you described.
Exactly. That one is using the number.
So then that means you don't use the normative knowledge. Right?
Yeah, that doesn't use the normative
So
knowledge.
can I understand this way? The situational knowledge essentially decides the move speed towards the elite.
That's
on
maybe the highest limit for example, because currently we have the best.
就是那个妍姐说跟牧师约的中午12点是的，
哦，马上去，你也
然后
去是吧
说让你12点钟就到。
？OK，好，OK，好嘞，OK，see you。
Yeah, the situational at least defines 2 things at least. One is the direction, so we know that we have some flag on the top of the mountain. Everybody should climb toward that, right?
Yes.
That's one thing. Is the direction, gives the direction. The other thing is that it gives the highest possible, for example, for the current generation, the highest possible number, right? So it says I have the best options right now because I got the best fitness. So that's a promising one. So at least everybody should resemble that.
Right.
So yeah, but the size, the normative, which the situational is one of those elites of 20%, right? So they define the range, the size. So I'm using this, as you mentioned, is like to define somehow a speed. So for
And
example,
the speed on each task. Each task has
each
its
task.
own speed.
Exactly.
Right? So you have
because
you
for
have
everyone we
yeah.
have a different range.
Right. So each task, some tests will go faster.
Exactly.
The other
So
tests go faster.
it's a space that data point maybe go this way or this way. So it's a different dimensions, right?
So can you write a sentence like this if it's fair? The elite give us a direction.
I think we have something like that,
But
right?
The elite,
Yeah,
the elite decides the election of everybody should, as
Yeah.
you said, converge or resemble.
Yeah.
But how fast you are going to resemble is decided by the normative. So the
Yeah.
normative
Can you
decide.
write it down for
Yeah.
The
example?
normative
No.
decide the
Okay.
speed.
Oh, you are recording
The
already.
normative decide the speed on each task. Each
Yeah.
task is going to follow the example.
Exactly. So in that dimension, we need to go faster. For example, get closer. Let's
So in
say.
this way, you give some kind of a, intuitive idea
Yeah.
of how each one is influencing.
Yeah.
Okay.
Exactly. So maybe in that, like for example, in that generation, we will come up with a better solution that will will serve as a new elite or new situation.
Yeah.
So we just keep.
The only question maybe he's here.
I think the example illustrates very well in terms of how the elite influence the next generation, but more detail is needed for how the normative knowledge is going to influence the speed in this case.
And also we need
Okay.
to mention if probably maybe that elite is just a local optimal, right? Is possible, yeah, because the first generation.
Yeah.
But if there is somewhere is global, we need somehow to guarantee. Eventually, we can go to from
Yeah,
that form.
because-
That's where the GA
because-
component might comes in. The GA can mutation and.
Yeah, because right now, for example, the situational is
I have to go to catch the 12 o'clock meeting.
Okay.
We have a meeting at.
So at least we need this one now. We know that normative and situational knowledge somehow how they affect.
Yes. So if
So-
you can come up with a good example
Yeah.
to Ziae,
So
and
we
then you
need-
can try it, and then
Make it more complicated.
let's make the algorithm
So
complete.
the goal is to win that paper, yeah.
Huh?
The goal is to win paper 10.
We have to. And also GA and also WI.
Yes, yeah.
The 3 algorithm. I wrote.
Yes, I have, and I added actually to the abstract. Thank
Right.
you. Yeah. Okay, thank you.
We should be able to win, I think.
Mhm.
My understanding is because you can always incorporate their ideas.
Yeah. Put it in the.
And regarding the comprehensive elite, I remember that you had a question about the for example ties, or you remember so I explained it last time to Mahdi. I don't know Mahdi.
Yeah.
That how to solve that problem
Which
for the
problem?
majority vote.
I know the vote, but I don't know how the vote is going to influence the population. He just talked about the vote.
We are creating a new solution based on that majority vote and injecting it into the population.
Oh, okay.
So that takes a shortcut because it's a kind of average of the bests.
Okay.
It's like a new leader that has all the good things from different groups.
Okay.
So let's say we have subcultures in the population.
Mm-hmm.
Each of them they have one leader, and let's say I will create a artificial leader that has good attributes of all of them.
Uh-huh.
So I will inject it to the population to take a shortcut.
I see. I don't know if the software itself can allow people to record remotely. In other words, if he's in Ann Arbor and you are here, is it possible to record a discussion?
Yeah, I'm not sure.
It would be better if you guys can record the presentation together. That's what I mean. If face-to-face is not possible, then
For the class?
No, for
No,
the
for-
YouTube
for
and
the
so on.
YouTube for this paper.
Okay.
What we are doing now is Marty is making a recording
I see.
every week
I
before the meeting.
I see.
So every meeting he recorded, and then in the meeting we record it and share with you.
I see.
So every week he should be record better and better
Sure.
Yeah.
until everything is very clear.
Yes, okay. Right now it's still recording. Yeah. Okay, thank you, Dr.
Thank you so much.
Thank you.
Thanks for your time.
Thank you. So شما خواهی بری پایین، شما برنامه چیه؟
برم نماز